Now here's something to think about. When we solve equations, sometimes we get troublesome answers, like the square root of negative 17. Remember how negative radicands are a no-no under an even index root? So this is a problem. Now we know for one thing that this is not a real number. That's all we know. And it's because it's a square root of a negative number. That's not real. Well, now we're going to learn a cool name for the square root of a negative number. It involves imaginary numbers. So we've got real numbers, we've got imaginary numbers. So let's review here a couple of facts. Fact number one, the square root of negative 1. We have a name for that. It's the imaginary number I. The imaginary number I. Okay, that's how you say it. Whenever you see the square root of negative 1, you just say, hey, that's the imaginary number I. Now, here's something to think about that you probably already know. What happens if you take the square of I? Well, you'd be squaring a square root, so the radical would be eliminated and your answer would be negative 1. Therefore, I squared is the same as negative 1. That's just a fact. It's like a property of I. But the definition of I is that it is equal to the square root of negative 1. Now let's learn how to use this fact. We're going to learn how to simplify the square root of a negative number like negative k. Example, the square root of negative 1. Well, that one's easy. It's just equal to I. How about negative 7 times the square root of negative 1? Now, we're trying to trick you there a little bit. The negative 7 on the outside is not a big deal. The square root of negative 1 under the radical, that is a big deal. So negative 7 is just a hitchhiker that comes along, but we replace the square root of negative 1 with I. So the answer is negative 7 times I. Another example, what about the square root of negative 2? Well, on that one, we're going to have to do this in steps where we have a negative number other than negative 1 under the radical sign. Step 1, always factor the square root of negative 1 out first. So that's what we're going to do. We know that the square root of negative 2 is equal to the square root of negative 1 times the square root of 2. And the reason that's true is because when you're multiplying radicals, if they have the same index, square root in this case, it can be broken apart like this. The multiplication can be broken apart. So we know that negative 1 times 2 is negative 2, so it's okay to bust apart this factorization. Square root of negative 2 equals the square root of negative 1 times the square root of 2. So you factor out the square root of negative 1 in the front, and anything that's left over gets left behind in the back. Step 2, replace the square root of negative 1 with the imaginary number I. That's what it's defined to be equal to. So this is equal to I times the square root of 2. Step 3, simplify the square root of k if possible. Well, you know, it's not possible to simplify the square root of 2. There's no perfect square factor in 2 that can bust out, so we just leave it as I times the square root of 2. Now, step 4 is write your answer in a plus b times I form. Now, that's called standard complex form. And we should always write our answers in a plus bi form. Well, this one's kind of silly. It's equal to 0 plus the square root of 2 times I. That's the answer. And there's no sense in writing 0. It's just the square root of 2 times I. But oftentimes the book will write the I in the front. And the reason they do that is so you don't think the I is under the radical sign. It's outside of it. Now, if you continue looking at this problem, we have another example, the square root of negative 36. Step 1, factor out the square root of negative 1 first. So that's I times the square root of 36 when you change it in step 2 to I. And then simplify the square root of 36, it's 6. So we have I times 6, which is 0 plus 6 times I. The answer is 6 times I. And the last one, the square root of negative 12. Step 1, factor out the square root of negative 1. So it's negative 1 times 12. And then replace the square root of negative 1 with I for step 2. So it's I times the square root of 12. Step 3, simplify the radical square root of 12. Well, we can bust out a perfect square in the front. That's the square root of 4 times the square root of 3. And then evaluate the square root of 4. You get, for step 4, you get I times 2 times the square root of 3. And we usually put I in the back, 2 times the square root of 3 times I, but your textbook will put it in the front oftentimes for the same reason. I don't have that problem of the I looking like it's under the radical because I always hook the end of my square roots, and you can tell where it stops, and anything after that hook at the end is outside of the radical. So you could do that too.